Assalamu alaikum friends, my name is Zain and today my topic is axial load. In all engineering construction, the component part of a structure must be assigned definite physical sizes. Such parts must be properly proportional to resist the actual or probable force that may be imposed upon them. Thus, the walls of a pressure vessel must be adequate strength to withstand the internal pressure. The floors of a building must be sufficiently strong for their intended purpose. The shaft of a machine must be adequate size to carry the required torque. A wing of an aeroplane must be safely withstand the aerodynamic load which may come upon in its flight or landing. Likewise, the parts of a composite structure must be rigid enough so that not to defect or sag excessive when in operation under the imposed load. A floor of a building may be strong enough but yet may deflect excessively, which in some instances may cause misalignment of manufacturing equipment or in other cases result in cracking of plaster ceiling attached underneath. Also, a member may be so thin or slender that upon being subjected to successive loading, it will collapse through bulking. For example, the initial configuration of a member may become unstable ability to determine the maximum load that a cylinder column can carry before bulking occurs, or determination of safe level of vacuum that can be maintained by a vessel is of great practical importance. In engineering practices, such requirements must be met with minimum expenditures of a given material. Aside from cost, at times, as in the design of satellites, the feasibility and success of the whole mission may depend on the weight of the package. Thus, subject of mechanics of material or strengthening of the material as it has been traditionally called in the past involve analytical method for determining the strength, stiffness, deformation characteristics, and stability of various load carrying members. Alternatively, the subject may be trending the mechanics of solid deformable bodies. Mechanics of material is a fairly old subject, generally dated from the work of Galileo in the early past of 17th century. Prior to his investigation into the behavior of solid bodies under loads, constructors deduction lead to the following fundamental conclusions. The external applied forces to one side of an arbitrary cut must be balanced by the internal forces developed at the cut, or briefly, the external forces are balanced by internal forces. Later it will be seen that the cutting planes will be oriented in the particular direction to fit special requirement. However, the above concept will be relied upon as a first step in solving all problems where internal forces are being investigated. In discussing the method of sections, it is significant to note that some bodies, although not in static equilibrium, may be in dynamic equilibrium. First, the acceleration of the part in question is computed, then it is multiplied by the mass of the body, giving a force F is equal to ma. If the force of computer is applied to the body at its mass center in the direction opposite to the acceleration, the dynamic problem is reduced to one of the statistics. This is also called the Elmebert principle. Okay, hope you like my videos. Please like, subscribe and share.